Question 5. A stone is dropped from rest at a height of 140 meters above the surface of a moon where there is no atmosphere. After 6.0 seconds of freefall, it has descended a distance of 12 meters. Using this information, how far will the stone have fallen from its initial position after 18.0 seconds? This question tests our understanding of how displacement changes with time during freefall. So what do we already know? We know that when an object is dropped from rest, its initial velocity is 0. Freefall means the object is moving under the influence of gravity alone, with no air resistance acting on it. Since the stone is falling on a moon rather than Earth, the acceleration due to gravity will be different from the usual value of 9.8 meters per second squared. We also know that displacement under constant acceleration is given by the kinematics equation S equals ut plus 1/2 at squared. Now let us work through the solution, step by step. First, we identify the known quantities. The stone is dropped from rest, so the initial velocity u is 0 meters per second. We are told that after 6 seconds, the stone has fallen a distance of 12 meters. We can use this information to determine the acceleration due to gravity on this moon. Using the displacement equation, S equals ut plus 1/2 at squared, we substitute the known values. The displacement is 12 meters, the initial velocity is 0, and the time is 6 seconds, so the equation becomes 12 equals 0 plus 1/2 multiplied by a multiplied by 6 squared. Next, we simplify the expression. 6 squared is 36. Half multiplied by 36 gives 18. So the equation becomes 12 equals 18a. Now we solve for the acceleration. Dividing both sides by 18 gives a equals 12 divided by 18. This gives an acceleration of approximately 0.6667 meters per second squared. Now that we know the acceleration due to gravity on this moon, we can calculate the displacement after 18 seconds. Again, we use the displacement equation, S equals ut plus 1/2 at squared. The initial velocity is still 0, and now the time is 18 seconds. Substituting these values gives S equals 0 plus 1/2 multiplied by 0.6667 multiplied by 18 squared. Next, we evaluate the time squared. 18 squared equals 324. Half multiplied by 0.6667 is approximately 0.3333. So the expression becomes 0.3333 multiplied by 324. Multiplying these values gives approximately 108 meters. Therefore, after 18 seconds, the stone will have fallen about 108 meters from its starting point. This is our final answer. What did we do? First, we used the displacement equation for motion under constant acceleration, and the information about the fall after 6 seconds to determine the acceleration due to gravity on the moon. Then, we used that same acceleration in the displacement equation again to calculate the distance fallen after 18 seconds. Finally, we evaluated the expression to obtain the total displacement from the starting position. Here are the main concepts applied in this question. Free fall with no atmosphere means that the only force acting on the object is gravity. The relevant kinematics, or SUVAT equation, for displacement under constant acceleration is S equals ut plus 1/2 at squared. When an object is dropped from rest, the initial velocity is 0,